Page 549. Tangent. The word I want to make sure I identify here right away is the word incline. If you don't know what incline is, let's do what we should do. Let's look it up. Hey Siri, can you define incline?
As a verb, incline means feel willing or favorably disposed toward an action, belief, or attitude. Do you want to hear the next one?
No. So I see an inclined surface or a plane, it's a slope. So it's like how much the road is climbing or growing. So when we say the maximum incline for a safe wheelchair ramp should not exceed a ratio of 1 to 12, then that's like the rise compared to the run. When we talk about slope of a line, this is a real world application that affects the lives of many, many people. So if you're going to safely construct a ramp to help assist someone with mobility issues up to the entryway to your building, you make sure that it's not too steep so that if they were to lose control and their apparatus were to take them away, they would not be able to, they wouldn't be harmed, right? We want to prevent harm. So for us, we have this law, thank you to the Americans with Disabilities Act, that says that there is a safe, allowable incline to a ramp, and there are people, code enforcers, that go around and make sure that your construction project does not exceed safe levels. So in our case, the safe levels are 1 foot of rise to 12 feet of run, or 1 inch of rise to 12 inches of run. It's a slope. It's all about that ratio. The other thing that I like to consider, keep in mind, they've deemed it appropriate. And you'll notice this if you pay attention to, like, when you go to either the hospital or to the nursing clinic or some sort of thing that, is certainly medically inclined. But in any building, if there is a wheelchair ramp, you are not going to see it stretch for like 90 feet on end. It's going to rise 30 inches over the course of 360 inches, and then it's going to have a pause where you have a landing that's level ground, enough for the person or the wheelchair or the apparatus to be stable, and then it's going to grow again. So in terms of real world problems, like you guys, this 100% is solving real world problems using trigonometric ratios. So I'm going to go back to my other, this is the self-reflection document, and acknowledge that in lesson 2 with tangent, we talk about the real world problem of designing a wheelchair ramp for a safe operation. Now, Troy decides to build 2 ramps, and each of them is with a ratio of 1 to 12. So the first ramp extends from the front yard to the front porch, and the vertical rise from the yard to the porch is 2.5 feet. How does vertical rise of 2.5 feet relate to that ratio? Honestly, maybe I should go back to that ratio and add some information. I did draw a right triangle. I'm going to add that detail to it. But I want to make sure I add to the ratio. This is rise vertical, and the 12 is horizontal run. We should also notice that from like how long this vertical rise is to this horizontal run. And if that's the case, then we should be able to take the fraction 1 over 12 and compare it to the information that we know already, which is 2.5 feet is like in the same location as the 1. So 2.5 can go there. And then on the bottom would be the thing we don't know, which would be x. We don't know how long the ramp should go so that we can safely attach, fill a concrete pad or some sort of ramp, construction process that will give us the full surface length of the ramp, the hypotenuse as it were. But there it is. We have our theta HOA on this. That should be an O away from theta. An A is always next to. That's a 90. This 2.5 feet should go on the rise opposite side, and then X for the unknown horizontal run should go on the adjacent side. To calculate the length of the surface of the ramp, what we need to do is figure out these two numbers and then use Pythagorean theorem. So I'm going to go back up to this one. I'm going to cross multiply. And if I do cross multiply, I'm going to be multiplying 1 times x. So that's just, x. But then I have 12 times 2.5. Hey Siri, what's 12 times 2.5? I think I'll use the yellow calculator instead. So I'm going to take my yellow calculator. I've already got math from a previous video. If you watched it, thank you for watching it. I'm not going to delete that math. Just keep it around. 2.5 times 12 is 30. So then I know that 30 feet of run and 2.5 feet of rise are my measurements. I can now use those numbers in the Pythagorean theorem, a squared plus b squared equals c squared, to find the length of the ramp. So I'm going to say that a is 30. It doesn't really matter, but just be consistent that the two sides of the right triangle, they are the a and the b. C is the hypotenuse, and it has to be c squared. So a squared plus b squared equals c squared. We need to know what 30 squared plus 2.5 squared is. Hey Siri, what's 30 squared plus 2.5 squared?
30 squared plus 2.5 squared is 906.25.
So then we need to square root that number so we get the length of the ramp. So I'm going to use my yellow calculator for this, just so you also see how to do this. I'm going to go control square root 906.25, press enter, and I get a value of 30.104. In other words, C, the ramp, is 30.104. That's it. I'll move this up a little bit more so you can see it in the video. That is it for page 549, but there is definitely more to follow about the concept of slope to tangent to cotangent and then to inverse tangent. So thank you for watching this video. Like, comment, and subscribe, and I'll see you in the next episode.